Hey folks, thought we'd take a look at working through some of the items that was on the final exam, the samples final exam that I posted at the Course Compass website. And I thought we'd start off here with number 2. And number 2, I gave you the equation for this parabola, and I asked you to find the vertex, the focus, and the directrix of the parabola, and then graph the parabola. First thing I'd do, let me write this on kind of a red colored chalk, is I'm just going to write down the general form for a parabola. Okay, this is one of the general forms that you've seen. Keep in mind when the variable x you see as being squared, that tells you your parabola is going to be either a happy parabola or a sad parabola. So this is the general form, and from the general form, I can see that h has a value of -1 and k has a value of -1. Well, that tells me that the vertex, keep in mind the vertex is at hk, so if h is -1 and k is -1, the vertex is at -1, -1. So I know that already. That was one of the items that we were supposed to find. Also, look at this. You have a -4 here, but the general form is a 4p. So p must have a value of -1 in order to produce a -4. Let me make that note right here. P has a value of -1. Now here's how I do the graphs of these parabolas. Once I know the vertex, I'll come over here and start to construct the graph. Do a little scaling. So my vertex is at -1, -1. So right here's the vertex, -1, -1. Because P is negative, that tells me my parabola is going to be a sad parabola. It's going to be opening down. So I know that's going to be the maximum value. Now I use this value of P to find the other items that you were asked. You were asked to find the focus as well as the directrix. To find the focus, I have P as a -1. I am simply going to count. Here's my vertex, -1, 1. With a P value of -1, I count down 1 unit. That's the focus. I count down 1 unit, and that gives me the focus being at -1, -2. The directrix is going to be 1 unit. P is -1. It's going to be 1 unit above the vertex. So that means my directrix is the x-axis. It's the line y = 0. And I can now sketch the graph. Remember, the focus is always, quote, inside the parabola. Also remember that the vertex will be the midpoint between your directrix and your focus. So that's how I was able to use the counting trick. Once I found the vertex, and once I saw P at a value of -1, negative told me the parabola was sad. I find the focus inside the parabola, so I counted down 1 unit to get the focus, and then I went up 1 unit to get the equation for the directrix. So that's the vertex, that's the focus, that's the directrix, that's the graph. That's it for number 2. Okay, folks, here in number 3, I asked you to graph the ellipse and locate the foci. So I told you that it is an ellipse, so that should help you a little bit. I do have to mention this real quickly. With these conic sections that you're doing, if only one of the variables is being squared, either the x is being squared or the y is being squared, you have a parabola. If both variables are being squared, such as here, you have either an ellipse or you have a hyperbola. You know the difference between an ellipse and hyperbola is you see an addition sign, it's an ellipse. You see a subtraction sign, you know you have yourself a hyperbola. here's what I would do first here. I try to get it into my general form of an ellipse. So that means I'm going to start off by dividing both sides of the equation by 144. So if I divide everything over here by 144, I get x squared over 16 plus a y squared over 9, and then that's equal to 1. Now, let me get this red chalk again. Let me write down my general form of an ellipse, x minus h squared over a squared plus y minus k, that quantity squared over b squared, equals 1. So that's the general form. And once I know the general form, keep in mind hk will tell us the center of the ellipse. That we weren't asked to find the center, but I'm going to go ahead and I'm going to list it anyways. The center is at 0, 0. We see a squared is 16. Well, if a squared is 16, that tells me a must be 4. B squared is 9, so that means b has a value of 3. Excuse me. Ellipses get me choked up. Tell you a little trick that has served me well over the years. I look at my general form for the ellipse. It's x squared over 16 plus y squared over 9 equals 1. And the larger number in the denominators, the larger number is under the x squared. When my larger number is under the x squared, that tells me that my major axis is going to be horizontal, x horizontal. If the larger number is under y, then my major axis will be vertical, y, vertical. So here I know it is horizontal because the larger number is under x squared. I know the center is at 0, 0. The other thing, well, we need to know the foci. So let's think, foci. Foci, I mean by red chalk. There's this little formula to help you for foci. C squared is equal to a squared minus b squared. So here we have a squared is 16, b squared is 9. So c squared is 16 minus 9, which is 7. So that tells us that c has a value of plus or minus 7. Plus or minus square root of 7. Now think about what that tells us. Since we know the center is at 0, 0, we're going to start sketching some stuff. Since we know the center is at 0, 0, and I know my major axis is horizontal, the A will give me the actual endpoints of the major axes, also known as the vertices of the ellipse. So if my center is at 0, 0, A is 4, 1, 2, 3. I count 4 units to the right, and I count 4 units to the left, and that gives me the endpoints of my major axes. Now my minor axes will be found by the b value of 3. B squared was 9, so b is 3. My minor axes, I start at the center, count up 3, and count down 3. That gives me the endpoints of my minor axes. I actually have all the points I really need to sketch this ellipse, and I'll try to sketch it. Kind of looks a little like Stewie Griffin's head. Now it's a matter of me labeling where the foci are. And the plus or minus square root of 7 tell me the foci. Remember, the foci will be on the major axes. So that means for this problem, the foci are on the major axes. The foci are at square root 7, 0, negative square root 7, 0, which, yeah, that's about, I'm going to say about right here and about right here. This is the square root 7, 0, and this is negative square root 7, 0. So let's see, we have an ellipse, plus sign equaling 1. The larger numbers under the variable x, horizontal major axes. The a value of 4, b value of 3 allowed me to label the endpoints of the major axes. That was a, just by counting, 4 units from the center. The b value of 3 allowed me to label the endpoints of the minor axes, just by counting. And then knowing a squared and b squared were 16 and 9 respectively, allowed me to get c squared as 7, which gave me a c value of square root 7, and I was able to locate the foci at square root 7 and negative square root 7. So that's it for number 3. All right, hey, here, folks, in number 4, I told you to graph this hyperbola and sketch the asymptote. So I told you it was a hyperbola. Quickly, I know it's a hyperbola because I see 2 variables. They're both being squared, and I see a subtraction sign in there. That's telling me hyperbola. My first step here would be to divide both sides by 36 to get x squared over 4 minus y squared over 9 equals 1. That puts it in the, that standard form of an ellipse. Let me write that down in red chalk. X minus h quantity squared over a squared minus a y minus k quantity squared over b squared is equal to 1. So we can see, remember the center of the hyperbola will be at hk. So since I don't see anything, that means my center is at the origin. The center is 0, 0. And I'm just going to make a note here that a has a value of 2, b has a value of 3. That's a squared, so if a squared is 4, a is 2. B squared is 9, that means b is 3. And I'm going to tell you a little similar trick to what I told you for ellipses. Hyperbolas have one of 2 forms. They're either this type of hyperbola, so branches like this, or they're like this. I know this hyperbola must have this shape because the first variable I see is x. If this were switched around and it said y squared over 9 minus x squared over 4, then I know the hyperbola would be doing this. So that's just my little trick. Here's how I do a graph. It's going to be a little different than what you've seen in your book. So let me get my coordinate axes here. Okay, first off is I notice that the center is at the origin. It's at 0, 0. I know it has this shape. So now I'm going to start to use some information that I've written down here. A is 2 and B is 3. If I go 2 units to the right of the center and 2 units to the left of the center, it gives me a point here and a point here. I've actually found 2 points on the graph of the hyperbola. So I know the hyperbola is doing this and it's doing this. Now the asymptotes. This is where I'm going to show you something a little different than what you've seen in the book. Asymptotes can be found by what the book told you, but I make what is called a fundamental rectangle. The fundamental rectangle. And here the coordinates of the 4 points, the 4 corners of the fundamental rectangle would be 2, 3, 2, negative 3, negative 2, 3, and negative 2, negative 3. Do you see how I came up with those 4 points? That's right. It's just combinations of the A and B I have here. I put down 2, 3, 2, and then negative 3. negative 2, 3, and then negative 2, negative 3. If I plot these 4 points, so let me plot those 4 points. There's 2, 3, 2, negative 3, negative 2, 3, negative 2, negative 3. Those 4 points define a rectangle. Here's the rectangle. If I make the diagonals of this rectangle, so here are diagonals of the rectangle, and notice the diagonals will pass through the center of the hyperbola. And now if I extend those diagonals, so just extend those diagonals, these extended diagonals, those are the asymptotes for the graph of the hyperbola. So I know the point 2, 0 is on the graph of the hyperbola. I have my asymptotes sketched in. They're the extended diagonals of the fundamental rectangle. And that's what I have for the graph of the hyperbola. So that's basically it for number 4. All right, hey folks, here in number 5, we kind of switch gears. We're out of the looking at the conic section stuff. And the rest of the practice here kind of looks like our work with sequence and series. So in number 5, I asked you to write the first 4 terms of the recursive sequence. And I gave you that the first term, a sub 1, is 6. And then a sub n is defined to be a sub n minus 1 over n squared. So here's how I do this problem. I'm supposed to list the first 4 terms. All right, there's the first term. A sub 1 is equal to 6. That was given, that's easy. A sub 2, now I follow this formula. So a sub 2 should equal a sub 2 minus 1. I put a 2 here, so I have 2 minus 1 over 2 squared. Well, 2 minus 1 is 1, so that's a sub 1 over 2 squared is 4. And then what was a sub 1? A sub 1 was 6. So I have a sub 2 is 6/4, but that reduces down to 3/2. So a sub 2 is 3/2. A sub 3, again, I'm just using my little formula here, putting a 3 in for the n. So I put a 3 in for this n and a 3 in for that n. So I have an a sub 3 minus 1 over 3 squared. That's a sub 2 over 9. A sub 2, we just found a sub 2 is 3/2, so I put 3/2 in here for a sub 2. So I have 3/2 divided by 9. And 3/2 divided by 9, that's, well, it ends up being 3/18, but that reduces to 1/6. So we have a sub 3 is 1/6. And finally, a sub 4, and you see the process now. I'm going to put a 4 in here for n, put a 4 in here for n, put a 4 in there for n. So I have a sub 4 minus 1 over 4 squared. That's a sub 3 over 16. A sub 3 is 1/6. So we have a 1/6 over 16. And 1/6 divided by 16 is 196. So a sub 4 is 196. So the first 4 terms of this sequence are 6, 3/2, 1/6, and 196. And that's all there is to number 5. All right, hey folks, here in number 6, I asked you to determine the sum of the series. And the series was we're summing from I equals 1 to 7, I times I plus 2. I'll just write it all out. I mean, it's pretty straightforward. We're starting at I equals 1, so we put 1 here for the I, and 1 here for the I. So this is what we have when I is 1. Series means sum. So now we add. The next value of I would be 2. So we put 2 in here for the I, 2 in here for the I, plus the next value of I would be 3. So we put 3 in there. Put 3 in for any I we see. Plus 4. Then the next value of I is 5. So we put the 5 in for the I's. Plus 6. The 6 has to go in for the I's. And I've run out of room, so I'll bring it down here. Put a 7 in for the I's, and that's where we stop. Because we started at an I value of 1, and we stop at an I value of 7. So before I go further, let's make sure we see this. This is what I get for I is 1. This is I is 2. I haven't used blue yet today, so let me use blue. This here is I is 1. This is what we get when we put in 2. This is when I is 3. That's what we have when we put in I is 4. This is what we have for I is 5. This is I is 6. And finally, I is 7. So now it's just a matter of doing it, or as I like to say, it's a Nike problem. Just do it. So you have a 1 times, well, 1 plus 2 is 3, plus a 2 times 4, 2 plus 2 is 4, plus a 3 times, that's 5, plus a 4 times, that's 6, plus a 5 times, that's 7, plus a 6 times 8, plus a 7 times a 9. And if you do this multiplication, you'd have a 3 plus an 8 plus a 15 plus a 24 plus a 35 plus a 48 plus a 63. You should get 196 to be the sum of that series. And that's it for number 6. All right, hey, here number 7. I gave you an arithmetic sequence, 2, 7, 12, 17, etc., etc., and I asked you to come up with the general term a sub n of the sequence. And then once you know the general term a sub n, I said, let's go ahead and find a sub 10, or the 10th term of the sequence. Now here's what makes this problem so friendly. Get my red chalk. I told you it was an arithmetic sequence. So we know for an arithmetic sequence, the nth term, a sub n, is equal to a sub 1 plus n minus 1 times d. D is the common difference from term to term in an arithmetic sequence. So let's just look and see what's happening. 2 to 7, that's a difference of 5. 7 to 12, 5. 12 to 17, 5. So we can see it's a difference of 5, a difference of 5, a difference of 5. So we can see right now that for this problem, we have our common difference is 5, and we also know the first term, a sub 1 is 2. So folks, all we have to do is just substitute in 2 for a sub 1 is 2, plus n minus 1 times 5. And now you just clean it up. Distribute the 5, and then combine like terms, and you get a sub n is equal to 5n minus 3. And then you can always check to make sure that this is correct. You know, if you put a 1 in for n, do you get the first term 2? If you put 2 in for n, do you get the second term 7? And it is checking. Once we have the general form for a sub n, the next part I ask you to find a sub 10. Well, a sub 10 will equal 5 times 10 minus 3. So a sub 10 equals 5 times 10 minus 3. That's a 50 minus 3. So you should have a sub 10 is equal to 47. That's it for number 7. Hey folks, here number 8, I ask you to find the sum of a series, and here it's n equals 1 to 10, n plus 5. And You know, we could do this one just like we did in number 6. So I'm not going to go over number 6 again. We could do it that way, but we have a shortcut. Since this is arithmetic, we have a little formula that when we have an arithmetic series, and this is only true for arithmetic, we have a little formula that looks something like this. It says to find the nth partial sum, it's equal to n times the quantity a sub 1, the first term, plus a sub n, whatever the nth term is, all that junk divided by 2. So check it out. We're trying to find the sum from n equals 1 to 10. So to use this formula, you need to find a sub 1. So let's do that over here. A sub 1. Well, a sub 1, you'd put 1 in here for the n, and you get a sub 1 to be 1 plus 5, so you get a sub 1 to be 6. Now, a sub n, since we're adding up the first 10 terms, a sub n would be a sub 10. And a sub 10 is 10 plus 5, which is 15. So to use our formula here, the sum of the first 10 terms, s sub 10, is equal to 10, n is 10, times a sub 1, which is 6, plus a sub n, or a sub 10, which is 15, all divided by 2. And if you do this, you get, a 10 times a 21 divided by 2, which gives you 105. So the sum of this series, the first 10 terms of the series, that sum ends up being 105. And that's it for number 8. All right, folks, here at number 9, I asked you to determine the general term a sub n of the geometric sequence. So I'm telling you this is a geometric sequence. Quick review on the difference between an arithmetic sequence and a geometric sequence. In an arithmetic sequence, consecutive terms have a common difference. In a geometric sequence, consecutive terms have a common ratio. So I'm looking at this and I'm saying, well, when I go from this term to this term, it looks like I'm multiplying by a negative 2/3. When I go from this term to this term here, it looks like I'm multiplying by a negative 2/3. And to go from this term to this term, it looks like we're multiplying by, that's right, a negative 2/3. So it is a geometric sequence. I mean, I told you that in the directions, but I know it now. And keep in mind that a geometric sequence is the form a sub n equals a sub 1 r to the n minus 1, where a sub 1 is the first term and r is the common ratio. So it looks like here our answer is just a sub n equals a sub 1, the first term, 1/5. The common ratio r, negative 2/3. And then that's raised to the n minus 1 power. And that's all there is to number 9. And keep in mind, you could check your answer to see if it's correct. Put a 1 in for n. Find a sub 1. Put a 1 in for n. Does it give you 1/5? And yes, it does. Put a 2 in for n. So 1/5 times negative 2/3 to the 2 minus 1, or first power. And that will give you a negative 2/15. So you can actually check your answer. But that's it for number 9. All right, hey folks, number 10. This is the last one I'm gonna do here on this video solution. I'm asking you if this infinite geometric series, if this infinite geometric series converges or diverges. Keep in mind, converges means that it eventually adds up to a number. Diverges means it will not add up to a number. So I'm asking you first if it converges or diverges, and then if it converges, to find its sum. Well, let's first determine if it converges, because if it doesn't converge, it would be a waste of time to try to find its sum. So here's how I know that it converges. I just kind of make some observations or notes. First thing I note, and it's the most important thing, is what's the common ratio R. So here the common ratio R is 1/4. Now what you should have seen in your text, the geometric series will converge if, so it converges if the absolute value of R is less than 1. Well, since we have R as 1/4, I do know the absolute value of 1/4 is less than 1, so that tells me that yes, this infinite geometric series converges. Now that I know it converges, I'm going to find its sum. And then let me get my red chalk out again, because this is a general formula. The sum of an infinite geometric series that converges is found by taking the first term, a sub 1, and dividing it by 1 minus r, 1 minus the common ratio. So for this problem, well, I think we better figure out what the first term is. So let me come back over here and to, let's do some work area. Let's get the first term. A sub 1 equals 7 times a 1/4. Then I'll put a 1 in here for I, to the 1 minus 1. So that's 7 times 1/4 to the 0. 1/4 to the 0 is 1. 7 times 1 is 7. So the first term is 7. So a sub 1 is 7. And then we have we already noted the common ratio is 1/4. So I put 1/4 in here for R. So I get 7 over 3/4. And 7 divided by 3/4, well, that's 28/3. So the sum of that infinite series is 28/3. And that's it for number 10. So hopefully you're feeling pretty good about the final exam. Hopefully you feel like you're ready to knock it out, and everything seems to be fine. I hope you found some benefit out of these I call them the video solutions to the practice tests that I put together for you on YouTube. Hopefully they've helped you. Hopefully they've helped clarify some information that you've learned in the process. And all that's left for you to do is go knock out the final. That's it. Thanks for watching.